good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
There, unmute.
There we are. Good afternoon. How are you?
Yeah, good. I had to find it for a moment. I was like, wait, where am I? What's happening here?
It usually takes us off mute, so I was a little surprised. Yeah, and then I came sliding in here. Actually had a phone call, spilled coffee, trying to answer questions. Yeah, it's been a fun last 5 minutes. Promise.
Yes. Oh, one of those kinds of days. You know what? I definitely recommend that you go back to sleep it off, and then reawaken.
Thanks, everybody.
See you later, guys. That's the only way to reboot that one.
Yes.
Oh, man. So good. Glad that you were here. It is really nice to see your face.
Good to see you.
Awesome.
I haven't talked to you today.
Very much looking forward to actually seeing your face in person at SC 23. We will be there in Denver, Colorado. It's coming up now, like 3 weeks away.
Is it 3? Is it 3 full weeks? I feel like it's less than that.
Is it less? Wait, what's today?
Let me look.
Today is Thursday, so it's 1, 2, 3. No, it's 3.
3. Okay.
Isn't it?
1, 2.
The 12th to the 17th.
We finished 2 more weeks and then we're there. Yeah, it's 3 weeks from now.
Okay,
but
yeah, that's wild.
We're running out of time.
This same time, this same place, in 3 weeks, we will actually be live at SC. So that's super exciting. If you've ever wanted to go and you want to see what's going on there, we're going to be live there. So that's really awesome. If you are going, please come and see us at booth 1855. And if you are going and you want to actually have a meeting with one of us, I think there's going to be like 20 of us that are going. So you get to have experts from like any of the millions of awesome things that we do at CIQ and the different open source projects that we support. We are more than happy to chat with you. So definitely come see us.
We're probably going to have morning and night shows as well every day. That's what we're talking about.
Oh, wow. Look at that little teaser.
Morning recap, afternoon recap. So join in.
Oh, wait. Okay. So you're saying like coming here live, like coming onto the YouTube channel live?
Every day, twice a day.
Oh my God. That's amazing.
Yeah. What we're shooting for. It's going to be a lot of effort. There's a lot of coordination that has to happen there, but these people know who they are.
Cool,
Thank you.
Cool. So I'll make sure to put my face on every day. We'll be ready to party.
So yeah, we're going to bring people in. Hopefully have customers come talk. So it's going to be exciting. Looking forward to it.
All right. I love it. And so, we were talking about collaboration. So that little intro that you did, talking about CIQ and collaboration, that's actually one of the things that we're going to be talking to today. So we have a special guest. I mean, of course, we have CIQ special guest, Dave Godlove, coming on. We have special guest from Altair, an amazing man named Eric. So I think that we should probably bring them on. There he is.
There we are.
Yeah. Awesome.
Welcome, everyone.
So much.
Hello.
Hey. Good to see you guys again, Zane, Rose. Wonderful to see you, Eric. We were just talking a little bit briefly before we came on about how it's been too long.
Yeah, my pleasure to be here again in your webinar. That's really great, amazing how you manage that. And yes, I listened to you talking about SC, so I hope to meet you in real life there. This will be also a great moment. And yeah, it's good that you will podcast many information also during SC.
Absolutely. So real quick, Eric, why don't you introduce yourself? And I'll go to Dave in a minute.
Yes, so myself, Eric Lecnew, I work in Altair since a very long time. In fact, I started and did my career in radios. So I will describe a little bit after what is radios, but basically it's a finite element solver. And let's say my original background is parallel computing. So my first task in radios was to work on the parallel version MPI. Was already there at that time when I started. And then I continue to evolve in Altair and in radios, being in charge of the whole radios development team since 7 years now. And since 1 year, in charge also of OpenRadioss, the open source version of radios. So I will let you give you more detail about that. But really enthusiastic about this new way to do collaboration work and to collaborate with companies like you. Very exciting and super happy to be there today.
Excellent. Thank you, Eric. Dave, I think everybody knows you, but why don't you go ahead and introduce yourself again for the 50th time?
Well, there might be people who are tuning in for the first time to this webinar. So Rose introduced me as a special guest. I'm not a special guest. I'm a total normal guest. But yeah, so I'm Dave Godlove. I used to be a scientist at the NIH, and then I became a systems administrator / staff scientist at BioWolf, which is the intramural HPC resource at the NIH. From there, I became interested in containerization. I was kind of an early community member in the Singularity Apptainer community. And so I've been around HPC containers for some time, and I've been working with them. And now I'm a solutions architect at CIQ, continuing to work with containers as well as some of the other awesome technology that we're developing. And I'm happy to be here talking with you, Eric, and talking about this great work and this great collaboration between CIQ and yourself here.
And you're always special to us, Dave.
Well, thank you, Zane. I feel the same about you and Rose, both.
Thank you. I know you do.
I also, Dave, just want to congratulate you. Like, we worked at a different company together, and you had like moved into management positions where you were doing, because you're good at that. Sorry, Charlie. You're a good.
He probably didn't want you saying that out loud.
Shh.
Talk to some of the people that I worked with in a management capacity before you say that, because I don't know how good I am at that.
Well, you were, and I did actually get feedback from your team, because that was part of my job, is to know what was going on. So yes, you were good at it. Not being good at it doesn't mean that you please everybody, but you were good. Okay. Anyway, so side note, but I remember you very clearly telling me I would so much rather get back into the command line, into the code, into writing stuff, into creating stuff and putting things together and working with people. So I am really excited for you to be part of this partnership with Altair and, you know, the other companies that we work with as well. So I know that you really kind of specialize in containerization, specifically Apptainer. But why don't you tell us a little bit what we're talking about here? So it's containerization, cloud, collaborations, the cutting edge approaches with Altair. So what is your kind of like viewpoint? And then of course we want to hear what you think too, Eric, and hopefully we're all on the same page. I mean, that's the point, right? But sometimes people have different perspectives. So tell us about it.
Okay, yeah. So yeah, you want me to introduce a little bit the code before, or you want Dave to introduce what you did with the containerization, or what you prefer?
Eric, if it's okay, maybe it would be good if we start with a little bit talking about Radioss itself and the code that goes into that, and then we can move from there.
Yeah, great. So yes, so just to recall that Radioss is used in the industry to run what we call crash analysis and also impact simulation. So in historically in auto, in aero, in rail, and also fluid structure interactions in defense and civil. And let's say it's spread to other domains like electronics, consumer goods, sports, healthcare, driven by this increased pressure from our customers to differentiate from the competition, to innovate faster. So what was, let's say, restricted to few domains, now it's more used in different industries. So for example, to look at the behavior of a cell phone when it drops, you need a software like Radioss to look at the product to be sure it's safe, it won't, let's say, break, and so on. So the idea is really to use those type of tools of solver to do what we call virtual prototyping. That is to explore the behavior of the product at the early stage of the design. So without having to build the costly prototype and to do a physical test campaign and to go back to the design after, you can do everything virtual and really optimize the product by simulation. With the idea to build safer product, more sustainable product, while optimizing cost and reducing time to market. Okay, so this is really the idea behind using the simulation. And to further democratize the usage of this type of simulation, about a year ago, Altair launched OpenRadioss, the open source version of radios. And the genesis of the project was really coming from the critical challenge faced by the manufacturing sector and especially the transportation industry, thinking about this move toward e-mobility driven by, let's say, the need to have more sustainable product to address environmental challenges related to climate change. So if you look at, for example, how we build car, this let's say increase the challenges to build them and also to simulate. Think about the effect of having a battery pack into a car and to assess the risk of short circuit of thermal runaway after a collision. So you need really to assess correctly and to have all the capability into the code to study the material and the effect post crash of such incidents. So let's say the answer and the conclusion from my team was really that with legacy code developed 30 years ago, we cannot cope with this fast transformation that requires constant adaptation of the software and also more and more specific knowledge, so more collaborations. So really, then this disruptive approach with OpenRadioss to democratize usage of explicit dynamics and to build this active community of users and also contributors with engineers, professors, students, researchers to increase the innovation pace and address those industry challenge with state-of-the-art research with this open platform. So it's really what we wanted to achieve. And maybe you want to explain maybe what you did and how we collaborate, because I think that's a wonderful example of how bringing people with different knowledge all together, we can do something really great all together. I think it's a wonderful example.
Yeah, absolutely. I'd love to jump in now. So thanks for that background, Eric. And so I think what I'm hearing you saying is that Altair decided to open Radioss and to create the open source version OpenRadioss, really to accelerate the technology and to accelerate the growth of the project. And so that's kind of exactly what happened right off the bat. So shortly after Altair made the announcement that OpenRadioss was now a thing, some people at CIQ got interested in it, and in particular, my colleague Yoshiaki Senda said, "Okay, well now this is an open source code, but researchers are still going to face some hurdles trying to install this software and trying to use it, and we can help with that by containerizing it." And so he jumped in, and I think within a matter of like a few days after the code had been announced, he had created a container and had written a definition file, and ultimately ended up creating a pull request back to the GitHub repo where the code is, so that this code can now be easily containerized. And I really get excited about this project because what really gets me excited about working with with this type of technology is when I see real world benefits. And a lot of times that there are real world benefits when you are working with HPC researchers, but you don't see them as somebody who is helping to just facilitate their research. You see that you got a researcher unstuck. You kind of know vaguely that they're working on interesting things. You see that you helped out, the HPC, organization that you're working with, and you got them, unstuck on something, but you don't see the actual real world benefits. And, with a collaboration like this, it's like, well, wow, you can really see how this is helping a lot of people, do really important stuff, crash simulations, helping the safety of people who are driving in automobiles, and, the safety of people who are using, electronics and other consumer devices. So I'm really excited about this collaboration and this work. I think it's really, it's really great. Yoshi went further than just showing how to containerize this work. He's written a really nice series of blog posts, and has also been talking about, he created and helped to create a pre-installed Oracle VM, which is available as one of the offerings on the Oracle Cloud, that has OpenRadioss and ParaView pre-installed, so you can just spin up an instance and tell it that you want a big beefy instance with lots of CPUs, and you can go ahead going that route. Once again, you don't have to install anything. You can just go ahead and spin one of those up and start analyzing your data. And then we've also been working a little bit, so that gets you to cloud, and how do you use this software, number one, in a container anywhere you want to use it, number two, on a cloud platform on a big instance. But then how do you, so OpenRadioss is a great fit for Apptainer because it's HPC technology. You spoke a little bit about your contribution, making sure that Radioss and then OpenRadioss can utilize MPI. And so how do you use that to its fullest extent now? How do you scale that beyond a single node? And that's the next thing that we've been kind of working on too. We've been using this OpenRadioss container with our Fuzzball platform, and scaling this up to not just 64, 128 cores or whatever, but actually multiple different nodes, multiple different cores within multiple different nodes, and experimenting with that and seeing how we can speed that up too. So we really had a lot of fun with this, and hopefully we're really helping the community out a lot as well, and enabling people to run these models and do these simulations, and hopefully helping to get a lot of productive work done.
Yeah, that's really excellent. And I mean, maybe I can, let's say, comment a little bit how it is helpful for the community, because in fact, with this approach of containerization, it allows to automatize source code synchronization from GitHub, compilation, execution, everything in a container. So this avoid to search the different components with the risk of version mismatch and things like that. You have everything, and it's becoming like a press button, I would say. Very simple, easy to use. And in fact, for OpenRadioss, it's critical. Because I need to explain a little bit how we architecture between OpenRadioss and Radioss. That's important to understand for the audience. So the OpenRadioss is our, let's say, upstream development version. It is continuously improved by this active community. The code is freely available, so everyone can download it and use it, and also can contribute to it, so do modification of the code. So this means that OpenRadioss is constantly evolving, okay? So everyone can access the latest and the greatest contribution from the community, okay? And use that to test new features or to add new features. And even if we put a lot of care to keep OpenRadioss very stable by running automatic regression tests, by having a pull request reviewed by professional maintainers and so on. It's still a development version. So you take the latest and the greatest, but at the same time, you can have the regression with feedback. We can improve it, add new functionality, new enhancements. So, I mean, if you work with OpenRadioss, it's very important to have a, let's say, smart and efficient way to update it automatically. And with the work from you, CIQ, it's becoming very easy to do it. And then you can run it on anywhere you install Rocky Linux on container, or you can run it in the cloud as you explained. So I think that's very important. Okay. I just want to add also that the way we architecture it is that we have the OpenRadioss, and at the same time we keep also a commercial version because we have some other customers that maybe prefer to wait a little bit to have something more stable, more qualified, to wait that we solidify, we improve the new features, so they are ready to wait, but to have something more stable and with the support from the professional Altair people, with maintenance, documentation, and everything bundled. This is possible, but at the same time, for people that really want to interact, to collaborate, having this access to OpenRadioss and this easy way to compile it and to update it is very fundamental. And at the end, this will also increase the innovation and the, let's say, interest and the, let's say, easy access to the source code, which is something that we know that even if for us that develop the code, it's easy. For people in the community, you really need to have things which are really streamlined, very automatic, very easy to use. So that's great.
So Eric, I know that you can obviously containerize OpenRadioss. I'm assuming that means you can also containerize Radioss. And when you do that and you put it in cloud, how does that impact the licensing model you guys have? Or have you had to change the way that works because of containerization?
Yeah, so for OpenRadioss, I mean, there is no license; it's open source. So I mean, this is really great because this means that you can run, let's say, many simulation without increasing the cost. And if we look, for example, at new technology like AI, machine learning, where you really use the simulation to, let's say, build tons of data and to use those data to improve your design by generative design and techniques like that, really you need to run more and more simulation. So having, let's say, the possibility to use open source software without license costs is very important, whether it is containerized or not. Okay. For the commercial version, Altair is quite unique in the simulation scale, because we offer a business model which is very flexible and which maximize the return of investment of our users, because we use the same pool of license to run radios, but to run the other solvers, to run the pre and post processing. All the catalog of application available from Altair, you can run it using those units. And you can also use those units to run, let's say, partner applications. So you see for Altair customers, running the commercial version is also almost free. Okay, so I think this is really appealing. So I see more the difference between the open source and the commercial version, between people that really want to be participating to the development, be involved in the community, in the future of the software, then the OpenRadioss is the right tool. Or some people that prefer to have really deep, let's say, qualification of the code and things like that. And then the commercial version is also very, very important and very stable. And for sure, what was done with OpenRadioss, it can be done also with the commercial version regarding containerization and things like that.
It's really exciting because we do run across quite often third parties software that has a license associated with it. Can become very difficult when you move into the cloud or you containerize and move into the cloud. So it's exciting to see you guys looking at it from a different view and finding a way to make a business model that is flexible enough to do that. So thank you guys. It's very exciting.
And maybe another aspect which is also very important with the cloud is that you have both the way to access, let's say, the software easily, but also to have, let's say, access to hardware capacity. Okay. So, and this is very important because what I didn't say is that, and explain, is that Radioss is using what we call the explicit time integration scheme. So this means that to run a simulation, which is very highly nonlinear, okay, like a car crash, like a drop test of cell phone, you need explicit time step solver because it's let's say it's not possible with implicit kind of simulation to converge. Okay, it's too highly nonlinear, and it's possible to converge with explicit code because you use a very small time step. So this means that you have big models and you need to iterate a huge number of cycles, so something like 100,000 of cycles. At each cycle, you need to solve equations, okay, to compute stress and strain at each node of each element. And a typical model in the crash industry is more than 20 million of elements. So you see how compute intensive it is. So to be able to run a simulation in a decent amount of time, we put a lot of effort to make the code parallel. So to be parallelized with MPI and OpenMP and a mix of MPI and OpenMP. And having access to the code means that you can use the latest and greatest CPU. So you can scale in by having CPU with a huge number of cores. And you can scale out because then you can use in parallel many instances, many nodes by using MPI. And with the cloud and with the open source, this means that you can do it at a very low cost. And this is very interesting because then this means that you can run a simulation faster, but you can also run multiple simulation in parallel. So you can, let's say, innovate faster at the end. Okay, so that's what the cloud also allows users.
I think we should remember too that some of the viewers here on the webinar might not be familiar with this software. Maybe now would be a good time to just kind of do. I can do a little bit of just a visual demonstration just to kind of make sure that everybody's kind of on board. And let me go ahead and show. So we've been talking a little bit about this OpenRadioss software and what it allows you to do, and essentially allows you to model, as Eric just said, at multiple points in time, what it looks like for instance, a car to crash. And so this is the results of this is just in a single timestamp. We're viewing this in ParaView, but this is just like in a single timestamp of a particular Toyota automobile. And this is these are real data from a real simulation that we carried out as part of this effort to try to containerize this code. And I mean, you can see this is just a single time step. So it took multiple different time steps to get to this single point. And you were talking a little bit about how many different elements is present in one of these models. So I can go down here, and I think that I can, if I can remember how to do it, I can make this a little bit more opaque so you can look inside and you can kind of see, all the different little elements of all the different pieces of this automobile that all have to go into this simulation and interact with each other and, rupture at certain points in time and so on. And so when you put all that together, you end up, I've got something I can show here. Here are multiple different time points. And this is something, once again, that Yoshiaki Senda put together. But you can see the color coding here gives you an idea of where the stresses are being absorbed in this automobile. And so you can see multiple different timestamps as this crash goes along, where all the stress is kind of carried mostly through the hood and the front end, and then gets carried through the frame and here and so on and so forth. So this is the kind of information which is what you're modeling. And so now, because of this, you don't actually have to, go and build a car and crash it into a wall and have a bunch of sensors and gather all the data and everything. Instead of that, you can just, have this digital car and crash it multiple times and gather all the data, as you change things and so on and so forth. So this is, I know that you already explained all that, Eric, but I think that sometimes, a series of pictures can really help somebody understand a little bit better, what the software is doing and how it works. I also wanted to talk a little bit. We were talking about the open sourcing of this. So maybe now would be a good time to ask. I'm going to step on your. I'm sorry, Zane.
You're good.
If you don't mind, so I was curious. I went over to the GitHub repo. So we're about a year into this open sourcing effort, and so I went over to the OpenRadioss GitHub repo, and I noticed there's a lot of different contributors, and there's a lot of different there's a lot of issues which have been closed, and some ones that are still open. And I also see that there's other things within the OpenRadioss group, such as the model exchange, which I guess this work facilitates as well, because it allows people more freedom to be able to hone and create and help to make better these models. So I'm wondering, can you comment on how this open source collaborative effort is going a year in?
Yes, it's a good point, because I mean, we open source, it was on September 8th, 2022. So about, let's say, a year ago. And indeed, it's really nice, because CIQ was one of the first supporters and contributors to this project. Indeed, the day of the launch, we were surprised, because we launched OpenRadioss.org, and at the day of launch, we had something like 40,000 connections to the website. So it was amazing to see how many people from all over the world coming to see and to learn about this initiative. I think it was also because it was the first, let's say, big code like that in explicit that went open source. And since then, we have, let's say, a lot of traffic. I mean, I think that we have, in average, 400 downloads per month. So for kind of still niche application, it's a lot. I mean, compared to the type of software which are here since long, it's a lot of downloads. Okay, and we have a very, let's say, fast-growing community. So I mean, we had 2 events. We had the first event. It was the last December in Paris, and we had also the honor to have CIQ participating to this first event. And it was, let's say, a French event with Altair, and then it was a nice success. And then we decided to have a Users Day. So this happened in end of June in Aachen, in Germany. And this time it was a full day event, and again, very nice to add CIQ sponsors the event, and also went to do a presentation. It was your colleague Björn Adamski that went in person. I think that all the community was there and very exciting about the different presentations. By the way, all the presentations are available on openradioss.org/presentation. So you will retrieve a presentation from CIQ, but also for all the, let's say, the community around radio. So we have people dealing with battery. We had the University of Aachen, which is working with OpenRadioss on a pioneering project of SkyCab. So you will see also the explanation about the SkyCab, which is really a nice way to illustrate this transformation in the transportation industry. Okay, with new type of things where you need to design, let's say, to deal with composite, with batteries, with autonomous vehicles, something like that. So it's really important, and it shows how dynamic is the community. And as you said, in parallel to those events and this community that is growing every day, we try to put more things available, because we think that it's really important to ease collaboration and to ease access to the software. So we work on, let's say, having readers to be able to transform the code and to support, for example, output with ParaView that you demonstrated, to have workflow using other tools, other open source tools. We also put models available. So we have this model exchange database that is also free models for everyone, so everyone can use the models and start understand how to develop models with radios. So I think that's also participate to democratize the usage of explicit simulation, to give models and models also that you can use to build more complex models, so the bricks that you can reuse and in a very free way, because it's also open source model. And yes, I think that it's growing every day, and it's a worldwide community, so that's nice. So we want also to continue, and probably we will have a users meeting in other region, thinking probably in the US next year, something like that, in order to continue to have the opportunity of everyone to join the community and to participate remotely, but also in person. So that's very nice. And one thing that I didn't say is that in addition to all the help from CIQ to automatize the code, we also want to give more insight on how to use the code, how to interact with pre-processing, with post-processing, how to set up models and things like that, and how to develop with OpenRadioss. So we also launch a YouTube channel. So from the website, you can retrieve the YouTube channel, which is at OpenRadioss community. And inside this YouTube channel, you will retrieve, let's say, a mini tuto. It's a short video, so you can look at what you want and get insight about how to join the community and to start work with this project.
Thank you for that, Eric. And we are posting those links. Sorry, I doubled up.
I see that.
Thanks
a lot. Yeah.
The next one's coming back to the YouTube channel for OpenRadioss. So thank you for pointing that out, Igor. Oh, lost my place here. Sorry, Dave. I'm going to step on you if you're going to ask something. Rose, I heard a voice.
I was just going to comment that I love open source. Open source is awesome. It's really great to see the community just come and collaborate and just come together around a project the way it does.
Yes, amen on that. And so I think that Dave, you're going to show us something. Yes, are we about to share a little Dave screen or?
If now's an appropriate time to do so, I can. Yeah. So we've talked a little bit about the effort that has gone into creating the definition file to containerize OpenRadioss. And then we've talked a little bit too about the effort that Yoshi carried out to create the VM on Oracle Cloud that is pre-installed, so you can just grab it and scale it up to however big of a single machine you want to do. But then the next step is, obviously, this is one of the reasons that Apptainer is such a great fit for OpenRadioss, is this is MPI enabled code. So the next step beyond that is, how do you scale that to multiple machines and start using that across an entire cluster, either on-prem or out in the cloud? And so we've been working on that problem a little bit with our fairly new product, Fuzzball. And I can go through a little bit how we've been working on containerizing and running this as a job with Fuzzball, running this as a workflow with Fuzzball. Okay, let me go ahead and share my screen again. So just if you haven't been following, or if you kind of forget or whatever, so I like to tell the story of Fuzzball kind of this way. So about 5 or 6 years ago, people within the HPC community got really excited about containers, but the existing container solutions that were there were not a good fit for HPC. And so because of that, the open source community got busy, got to work, and created a solution, a container solution that ultimately became Apptainer, which was well suited for HPC. And we've seen the success over the past 5 or 6 years of that effort, and just how Apptainer's really taken over containerization within HPC. Now we're at a similar inflection point where the community is excited about orchestration, and we're looking at job orchestration. We're looking at container orchestration, and we're seeing that the orchestration solutions that currently exist, while great for what they do, are not a good fit for HPC, really, for a variety of reasons. And I would say that the biggest kind of underlying mismatch is a focus on services instead of a focus on jobs. So in high performance computing, what you want to, when you want to orchestrate containers, you want to orchestrate them based on jobs. And that's kind of a completely different philosophy from what it currently exists out there. So enter fuzzball. So this is what fuzzball is for orchestrating jobs, specifically containerized jobs. And so I've been working, Yoshi and I have been kind of working on this together back and forth across different time zones and different work days, but we've been putting together a workflow that will run basically the model that I just showed you previously, the Toyota Yaris crash test that I just showed you a few minutes ago. And it's a kind of a nice model that we can use to do this. So I'll kind of step you through and kind of show you what this looks like. So let me go to maybe it'll be better to go to the workflow here. So really, this is a workflow which consists of 3 different jobs. There's a pre, which kind of does a little bit of setup. There is a workload, which actually, calculates the model and does the heavy lifting and all that. And then there's a post, which essentially all this post does is tars up the data and then puts it in a place where you can get it later. So if we look at this, there are a couple different volumes. There is a volume called input, and that volume is an S3 bucket where I've actually placed this model and some of the files that we need in order to run the model. Maybe I can make this bigger. Hopefully, that messes up the.
Perfect.
There we go. Okay, so there's this input S3 bucket, and so this volume is like sort of mounted onto the job. You can kind of think at runtime. And then we've got another volume, let's see, which is going to be this OpenRadioss volume. And this is where the data is untarred to, and actually the work takes place. And then ultimately where the final output is tarred up and then moved. So if we go in and we look at these, so the pre portion of this, if we look at the environment here, we can see that we're using this OpenRadioss container that we have up on that we've got up in the Google artifact registry. And then if we look at the actual command that's run, so here we're essentially just doing a untarring the data, and then we're CDing to the correct directory, and then we're running the actual OpenRadioss command, which in this case is starter_Linux64 GF. And what this does is it sets the model up, and it sets the model up according to the number of different ranks that you want ultimately to be in your MPI job. In this case, we are specifying that we want 72 different ranks to all run simultaneously. Okay, so now if we go into the workload portion of this, we see the command that runs down here, and that's another OpenRadioss command. It's engine_Linux64, and this basically you point it to the first file, and then it kind of it invokes or is invoked by an MPI command, which then looks at the number of files that it has and starts to work on the data according to that. Now, how do we get MPI to work here across multiple different nodes? Well, this is kind of the cool thing about fuzzball is that if we go down here, we see that we've selected the job type to be multi-node, and then we've said that the implementation in this particular case is going to be OpenMPI, and that's because this image we have compiled with support for OpenMPI in the image. But really, all you have to do is you have to click this button that says, I want this to be multi-node and I want it to be OpenMPI instead of MPitch or GasNet. And then, excuse me, when you go over here, resources, your resources just have to match, the core. So in this case, I want to go multi-node. I don't want to just have everything run on a single core. So I want 18 different cores per node. And then if we go back and look, the number of nodes that we're going to do is 4 nodes. So that works out to the 17 different ranks that we need. So that's how all that works. And it's as simple as that. And, if you want to click around and create your job here, that's great. If you don't want to, you can go over here and you can, so what under the hood, what this actually does for you is it creates a YAML file. and you can, everything is specified here in this YAML file that you can then submit. And I find that it's useful to kind of go back and forth between these. If I don't really have any idea what the YAML spec ought to look like, I'll kind of rough in some values, and then I'll, save it, and then it'll generate the appropriate YAML for me. And then I can go in here and I can fine tune things and look through and kind of see what the values ought to be. But if we go down, so all these jobs are dependent one upon another. So we've got this pre-job here, and we've got the post job. They're kind of out of order. But if we go down to this workload job, and if we go down here to resources, we can see, once again, multi-node, 4 nodes, 18 cores. That's how all that is specified within the YAML file. All this can be, so this is all API driven. This can all be carried out, either at the command line or through this GUI. But, once you're ready to go, you just start the workflow, give it a name, or don't give it a name if you don't want to, and just, get it going. And then if you go to the status, you can see that the workflow is running. And it's really as simple as that. So I'm going to go back to, this takes a little while to run. So I'm going to go back to the previous workflow, and we can kind of like look at it. Let's see. And I've been tinkering with this, so I've got several of them that have failed or been canceled. But if we go back to this one here, so if you go in here and look for logs, let's look at all the logs. Actually, let's look at all the logs. So this is going to look familiar to you if you've ever run OpenRadioss before. So it kicks off and says, okay, I'm going to do this with 72 processes, and here we go. And then the data is ultimately tarred up in this job here. And then as the final step, we transfer the data back out to this S3 bucket where I can download it to my local computer and use it to visualize, like I showed you earlier with ParaView, or do whatever I need to do with it. So that's what we've been working on to kind of take OpenRadioss to the next step, which is across multiple different nodes. And it's easy to do because the architecture of OpenRadioss is so nice, and also because Fuzzball lends itself so nicely to running containerized jobs with MPI.
Yeah, really impressive. And I just saw some, let's say, community exchange on the forum about multi-nodes and things like that. So I am sure that the community will really appreciate to use such tool to deploy on, let's say, multi-nodes.
Yeah, absolutely. Yeah. And so that's actually running on the cloud under the hood. It was actually running on AWS, but Fuzzball runs multiple different places. You can do the same thing on-prem or different clouds. You can use EFA. That particular example doesn't use EFA, but if you need a high-speed interconnect, you can use that as well. So yeah, it's pretty flexible. And I once again, I get excited about when I see our work having real-world impact and helping people. And so I'm excited to see this do the same and keep on carrying that through the open source community.
That was awesome, Dave. I also just want to give another little shout out to Altair is going to actually be in our booth at SC23 on Wednesday, the whatever that is. I think it's the 15th. I think so. It's the
Now you're gonna make
15th
me
of
look.
November.
That
Yeah,
sounds right.
we don't have a. What's that?
I said that sounds right. Now you're gonna make me look.
Yeah. I think that's right.
It is. You're right. The
We don't
15th.
have an exact time yet, but you guys are actually going to be in our CIQ booth, so 1855, doing a demonstration with Fuzzball. So I think that's going to be really exciting to see somebody not CIQ right, getting in there and playing around with Fuzzball. And, hopefully it goes smoothly. And then also there's a little part of me that's like, break everything so that we can fix it and make it better, and like that's kind of the fun of it. So very exciting. We're very excited to see you guys. And Eric, I do actually have a question for you. So hopefully I'm going to pronounce all of this right, and we can go with that, because sometimes a little techie type stuff, I'm like, go off on a tangent. So I've heard that CIQ use some test model in LS Dyna input format. Can you tell us a little bit more about that?
Yes, that's a good question, because this is what we saw today, in fact, because for, let's say, specialists, you recognize the star K, which is, let's say, LS Dyna format. So the idea is that, let's say, since a few versions, Radios and now OpenRadioss is able to deal natively with LS-DYNA format. So we understand that this other solver is very popular. Okay. So many engineers and researchers already know this format. So we wanted to lower, let's say, the entry barrier to use OpenRadioss. And to support natively this popular format, participate to make OpenRadioss, I would say, more accessible to a wider community. So not rather those who knows Radioss format, but also those who knows this other format, and they can just take their models and run it with OpenRadioss, okay, without modification of the input deck. So I think that's really great. To be able to start and to continue to use, let's say, the way you know how to model models, but using another solver. And in fact, we were able to do that because indeed, LS-DYNA on Radioss shares the same root, which was the DYNA 3D research code in the 80s. So this was at that time that one of the first, let's say, explicit code was built, and then there were several, let's say, different codes spread over the world. They evolved, let's say, in parallel, but they had quite similar functionalities. So it was more a way to be able to understand this language and to interpret it with Radioss natively. And this is what we have been able to do. And now we are helped also by the community to continue to spread and to support more features with this, let's say, alternative format.
That's awesome.
great.
Yeah,
Thank you for that.
I know that
And to Rose's point earlier, we're actually going to try to stream all of those demos that we do in the booth too. So if you can't be there and you can't see Altair's, come back to the channel. We're going to try.
I've heard that
I'm not going to put too much stress
internet
on everybody and say we are going to, because I know it's a lot of effort and I know we're doing our best to try, but we're going to try.
We are going to try. That's awesome. So I know we're pretty much coming up on time here, and I really want to respect your time. And Eric, I'm so grateful for you being here. I don't even know what time of the day it is for you, but I imagine that it's not 11 in the afternoon like it is for me.
Yes, it's a little bit late, but that's good. Generally during work hour, I am really occupied and busy. So in the evening like that, it's easier for me to be available and to participate to great webinar like this one. It was really my pleasure. Again, I want to thank CIQ for this opportunity and for his support of our project, of this community, and all the work, all the effort to democratize and to participate, to spread OpenRadioss by making it even more accessible. So big thank you to you, and my pleasure to be there.
Oh, and thank you to you, Eric, and Altair as well. Yeah, this has been a lot of fun working on this, and I look forward to continuing to see us work together on this.
Yeah,
absolutely. Thank you very much.
Awesome. All right, you guys. So thank you everybody for watching. Thank you for sharing this amazing demo. We got 2 little demos in there, so that was really cool. We got to actually see it in action, then see Fuzzball in action. We've got the backstory to Altair and OpenRadioss, and it was just absolutely a great show. So thanks for listening on our podcast. Thanks for watching on our YouTube. And make sure that you come back. So same time, same place. We will be here next week. Thank you very much again, Eric, for your time. And Dave and Zane, you're amazing. Have a great week. Bye.
Thank you, everyone.
Thank you, Rose, Dave, Zane, and see you in a couple of weeks in SC in Denver.
That's it.
See you there.
See ya.
Good morning, good afternoon, and good evening, wherever you are.